And OpenCV, I'm using the PY Image Search Gurus course. So I've given myself about a year to learn all of that and build a robot prototype that I can actually market commercially, because I want to do this as a, as a commercial product, to actually do this as a career. So yeah.
That's awesome. I've done the Pi image search tutorials. Has anyone else had experience with the construct tutorials?
Yeah, I'm a member of the construct.
Yes, but
okay.
Which tutorials? Because there are a lot. I think the videos, there are 100 videos.
Yeah, so I'm going to sign up for the monthly package, and just like work through whatever I need to get up to speed with you guys.
And so one question is, your commercial product, what are you envisioning? Are you envisioning a tractor style or?
So yeah, I'm hopefully a smaller tractor, something that can be used in a, in a vegetable farm that's like about a hectare, around that size. Deploy one machine per hectare, or a bigger, but I'm not sure how to, with a bigger one. Yeah. So we'll start with a small one and see.
Sure.
I say you guys have a lawnmower project Matt was telling me about. I think that sounds like pretty much the good size. Like that's manageable.
It's not so easy. It seems easy, but it's not easy.
Yeah, I can imagine.
Yes.
Okay, cool.
Yeah.
Thanks very much for welcoming me. Looking forward to working with you guys.
Okay.
Great, you're here. Allan has a robot for vegetable garden. You want to talk about that, Allan?
Yes, indeed. Yeah. Hey, welcome, Twanda. It's great you're here tonight. And I have a special guest here too. Ravi Sharma has been working with me and doing a lot of. He's been doing most of the work, so most of the credit goes to him. And if there's any problems, that's my problem. So anyway, he's here, and I thought if he could share his screen and just walk through a demo where we're at currently. And then one of the next steps that we have is to try to get MoveBase fully installed and ready to go. So we're working on that from a few different angles. So I know, Vinny, you've been helpful. A few questions on MoveBase. And so thinking about MoveBase, I kind of throw this out for the whole group to ask, get some input. It sounds like there's MoveBase, there's MoveBase Flex, and then ROS 2 kind of has its own path. And so before we got too far down a path and committed ourselves to one thing or the other, I thought maybe I should ask if anybody had any big pros or cons with going with one of those options versus the other. I guess if we go to ROS 2, then we've got to switch everything over. So maybe that's a leap too far at this point in the game. But at some point, it seems like, anyway, so that's kind of the question, is what people's thoughts are, big pros or big cons with MoveBase Flex, or should we really bite off a lot and go all the way to ROS 2 and whatever they're doing?
So I think the big advantage of MoveBase Flex is the plugins are backwards compatible with MoveBase.
Right.
So to me, it seems like the safe option is to go with MoveBase Flex over MoveBase because there is some compatibility. I don't know, does anyone else have any thoughts on that? Because I guess if you find move base flex unwieldy, which you won't, but if you do, you could always revert back to move base. But if you go into it with the approach that, hey, we're going to use move base, then you might not be able to do move base flex. And I think move base flex has the advantage that we wanted to take advantage of is the action to what do you call it? Man, I'm stumbling on that word, but the action to go to a predefined waypoint, predefined path.
Yeah,
So
that's kind of,
move base flex will be better with that than move base is your thought?
Yeah.
Okay.
so if you take a look at move base, you have a global planner and you have a local planner, and there's no way to interject in between those two things. And so you can't send in like a predefined path. Like if you already have the GPS coordinates, you know exactly where you want to drive. With move
Right.
base, I can't send that right there. I have to go through the global planner and then to the local planner. But what move base flex does is it opens those things up. Now you can use your global planner if you want to, but you can also send in a direct path with an action server, and then your local planner will drive it. And that's
That
what,
sounds a lot better.
yeah, well, yeah, it's more flexible. Move base
Yeah.
flex.
I did read that they had kind of pulled the different components apart so you could use them more as standalone versus less tightly integrated.
Jeremy's online, so he can give us the latest on ROS2 navigation. I'll throw him under the bus.
I haven't been playing personally a lot with Nav2, but what I do know that might change your mind is that on June 3rd is the final release of ROS1 as a distribution. And so what that means is that you got about 5 years of maintenance and no new features in the core of ROS1. And then who knows? I mean, it may live forever, but I suspect Open Robotics won't change its mind to support ROS1 beyond that maintenance window, just because they're super strapped as it is to maintain one or the other. If you're so inclined, there's a Nav2 working group that you can join, and I join when I can. The last meeting, they were talking about adding GPS navigation to Nav2, and they had a lot of cool new localization techniques that they were planning on adding. It seems like it's gained a lot of traction. There was like, I don't know, maybe 20 or 30 people on the call, and a lot of people doing a lot of good work around it. So we've used it a little bit at work, but I haven't really dug in deep. And it's kind of a whole new rethinking. So if I were you, I would look at trying it out. I know right now the examples that work in simulation are pretty, the one we got to work was pretty simple. I do like some of the interfaces. It was easy for us to write a application to drive to basically, we had a set of waypoints that we wanted to go drive to that location and take a picture or something. And that was pretty easy to do. But yeah, I think I'd take a look. They were talking also in the last call about a more robust simulation and beefing up the tutorials. So I guess my suggestion would be have a look, and if you're talking about ROS1 versus ROS2, there is kind of a halfway in between, but for NavStack work, I don't know that that's an option because it's, I mean, really, if you're just using the whole NavStack, then you're going to have to really just choose one or the other. But otherwise, if you're creating your own applications, there's quite a few different ways to kind of have a mixed ROS1 and ROS2 system. But other than that, that's my thoughts anyway. Thanks for throwing me under the bus.
Yeah, no, that's a good update. I appreciate it. That's good.
I think I mentioned this to you, Allan, but I think I read that NavStack or Nav2, it has like a whole army of interns working on in that working group because I think someone had offered, hey, if your internship got canceled, come work on this. So I guess that's one pro. There's going to be a lot of development happening. Another kind of thing I noticed and read about a lot is there's like a big fleet management tool that was released for ROS2. And if fleet management is something that's in your mind, maybe just starting with ROS2 or doing the upgrade now might be useful.
And by fleet management, if I think of swarms, is that similar or is that an entirely different universe?
Yeah, and again, I'm not certain exactly what this tool was. I just know it was getting a lot of buzz. But I think the intention was you have a group of 10 robots deployed out in the field and you're teleoping them. And it had ways to deal with shoddy connections and things like that.
Yeah, you certainly, if you had 10 rovers out in the field, you wouldn't want to teleop each one individually. You'd want some kind of treat them as a mob, and then, you know, they would have to fill in the gaps, you know. So if your area coverage, you know, each one could fill in a piece of the area. And if one drops out, one dies along the way, then that area could be picked up by somebody else.
Right, and I think it had aspects of monitoring and, you know, making sure each robot has a heartbeat or something like that.
Yeah, good. Well, I think maybe, unless other people wanted to chime in on that topic, I think, Ravi, if you're ready to share your screen, or, you know, I just wanted him to give an introduction and talk a little bit about some of the stuff he's seen, more in the industrial robotic space. But before he jumps in and talks about what we're trying to accomplish here, so.
Good morning from India to all of you. My name is Ravi. I'm a robotics engineer working in the field of industrial robotics and automation systems for last.
Hey, Ravi. Ravi, we're having a hard time hearing you. At least I am. If there's a way you can get a little bit closer to your microphone.
Now is it okay?
That's, yeah, right at the end there. That was much better.
So let me introduce you myself again. I'm a industrial robotics and automation engineer working in the field for last 11 years or more. I started journey across 3 years back, developing some small simulations, working on some interesting projects, developing most of the time I did simulation projects, developing an arm in the ROS and the Brazil environment to simulate it, to see how it works forward and reverse kinematics. So these were the things I started with in the ROS. I took a course, a very simple course on and I got very interested in ROS because I had the background of robotics. I did understand the mathematics of the robotics, so I thought that this would be the way to go forward. And then I took it professionally as well. So I got some projects online. I could deliver the projects. And luckily, a few months back, I had the chance to work with Allan to start developing the rover.
Let me let me share my screen for just a second here. I know we're having a hard time hearing there, but so this is Robbie's LinkedIn page, just so you can see that. So this is, 11 years working with the KUKA robots and Siemens systems. All right, Robbie, if you want to go ahead and I'll stop sharing. If you want to go ahead and share now, that'd be good.
Yeah, I can share 1 minute. Am I audible now? Is it okay?
It was, yeah, that's better. That's much better.
Sorry for that. I have some interruptions here. I can share the screen. Are you guys able to see the screen?
Yep.
Oh, great. So the project we are working on is the rover ROS, and it's basically developing the rover with a 5 degree of freedom robotic arm for the agricultural purpose. I will show you the basic gazebo simulation what we did for the rover, and then we attached a robotic arm on the rover and used move it to control the arm. The control of the robot, I wrote a simple script so that we can control the rover using the keyboard commands in the gazebo environment. So, in order to launch, so this is the rover. It has the chassis. We tried to keep it simple so that the rover doesn't take too much compute in order to get simulated in simulation, simulated in gazebo. So the chassis, we kept it very simple. We have four joints, steering joints. Front two joints are actually stirred, and they are based on the Ackermann principle. The back joints, the back two joints are the fixed joints for the steering, and all the four wheels, they are the continuous joints in the environment. So in order to control, I try to keep things simple in the development. So I divided the work in various packages. So I have the package for completely develop the rover in RVs or gazebo. So in that case, I kept one package, rover description package. It has the URDF meshes. So this package basically just launches this. It's just used to spawn the rover in the gazebo or RVs. Then I used another package, which is the arm description package. This package spawned the robotic arm in RVs or gazebo. Sorry. Then I tried to combine both of them. So I created another package which has the dependency of these two packages, and it spawns the arm plus gazebo plus the rover in RVs and gazebo. So I try to maintain the modularity in the code so that each of the package can be individually managed, and I do not have to bother about changes in one package and its effect on the another package. So if I make any change on the down the road, if I make any change in, let's say, one of the packages, other packages should not be, they should not be in a state where I won't be able to use them. So this is how I maintain the code. This is how I develop the code so that it will be fully modular and fully flexible to make the changes for the future purposes. So just I want to show you the rover, how the rover is. So it's a very simple model in the Zero. It has a chassis as a fixed joint, fixed length. Two front steering, they are the revolute joints, and they can be controlled by the keyboard commands, by the keyboard arrow keys, left and right. If I want to steer the rover, I can easily change the angle of the rover by using the keyboard arrow keys. The front and back maneuver can be done by the up and down arrow keys. So this is the basic functionality of the rover. As we can see in the video that while steering, it maintains the Ackermann principle.
Hey, Robbie.
Yes.
Yeah. Hey, Robbie. I think, do you have that on a second screen? I can't, I'm only seeing your first screen, I think.
Oh. Now I think it should be visible.
There it is. There you go.
Sorry for that. So this is the rover moving. I'm moving it using the keyboard commands. And as we can see, the rover is maintaining the Ackermann control of the front two steers. The right side steer is slightly at a greater angle than the left side wheel. So this is the rover. I would like to show you the rover plus arm.
So Robbie, let me stop there for just a second. So we're having a hard time hearing you. So I'm just going to paraphrase some of what you said there. So we've spent quite a bit of time here recently getting the Ackermann steering correct, so that the inside row wheels, when you turn, the inside two wheels have to turn at different speeds, and even the front and rear have to turn at different speeds than the outside wheels. Otherwise, you're gonna have a lot of slippage on the ground. So Robbie actually used MATLAB for a while to pull some of the data over and do some analysis to figure out what was going on there. So we think we've got that piece fixed now. So we have it in two pieces. The code's in two pieces. The first piece that he showed was the rover in Gazebo. And then once that's running, so we run that and control it with keyboard. But then once that's running, then we can do a second piece of code in a second terminal window. And then we can control, there's a rover arm, there's an arm on the rover in the front. And once he launches the second piece of code, we use move it, and that shows up in RViz. And then we can also see it in the Gazebo window. So I think that's.
Hey, quick question.
Yeah. Yep. Go ahead.
So you mentioned you spent some time fixing the Ackermann steering. Were you able to do that in Gazebo? Or was that something you had to put in a node prior to everything getting to Gazebo?
So we have a package which is doing the keyboard control of the rover, and in that package I have written a script which is acting as a node maintain the Ackermann control. Here is the package global residual control. This is the script global controller. This is based on the Ackermann. All the maths behind the Ackermann steering is maintained. It's developed in this controller. So
Yeah. Hey, Ravi. Yeah, that's on your. I think you're on your second screen with your Atom code.
Yes.
So we fixed it. To Vinny, to your question, we fixed it before it went into Gazebo.
Yes.
Okay, so it was not a problem with the actual model. It was just a problem with the way the messages were being, with the actual commands being sent to the simulation.
Yes. The problem was in the code itself. In the code
In
itself.
the commands itself, right, Ravi?
Yes.
Okay, understood.
Itself, there was no problem with the model, the URDF. The model was good. It had no problem, no issues with that. The only problem was that I was sending the theta to the steering, the same theta to both of the steerings. That was the problem. And it should not be the case. It should not have the same theta, otherwise the wheels will slip on the ground. So the the idea behind Ackermann is that if you are trying to turn left, then the inner wheel should have the higher theta than the outer wheel. So if let's say you are doing a counterclockwise turn, so the left side wheel, so the left side wheel should have a higher theta than the right side wheel. And if you are doing opposite, then the theta should be opposite on the wheel. It should act opposite on the wheels. So this should be the principle which should always be maintained. And then there is another thing in the algorithm that the wheels turning speed should not be equal. There should be on a ratio. Different. Each of the wheel will have a different velocity by moving. So this will maintain the Ackermann at the same point, Ackermann principle, and at the same point, it will also maintain the. It will also take care of the slippage in the ground. So last week I was able to fix it, and now we have better control over the whole. Now I would like to show you the movie.
So we're going to show the move it piece now that shows up in RViz. So I saw that the best way to think about Ackermann steering, I saw this in something I was reading this week. The best way to think about it is to think about it as a tricycle. You start out, you have two back wheels and then one wheel in the front in the middle. And so think of it as a tricycle, and the steering commands come in as one command to that wheel in the center front. And then you have to convert that into the angles and speeds for the two on the side. So if you think of that way, at least for me, that made the most sense. So the point I'm trying to control is that one wheel at the front of the tricycle, but then I have to convert that into the angles and speeds for the two wheels on either side.
I hope you are able to see both of the screens.
Well, we can see the RViz screen right now with Move It, and that's probably okay, just to show that one screen for right now while you talk about this.
Okay, so the idea is the Move It allows you to do, it's a package which allows you to do all the inverse kinematics of the robotic arm. The Move It package is basically used with the fixed arms. So if you have a, let's say, 3 degree or 4 degree or 5 degree, 6 degree freedom of arm, you can control this arm in the Cartesian coordinate system. So I use this package just to simulate this rover arm for some of the fixed points which I have defined in the space. So I define here, I define arm 0, home, lower, right, and left. These are the fixed points in the space for the arm that I defined when I was defining the movie package. And then I can plan and execute the trajectory. So let's say if I want to go from, right now I am on the 0 position. If I want to go from 0 to home position, I can select from here. And on the right side, you can see that it's already started to show me how this trajectory will get computed, how the planning will happen. When I select plan, it will start to show me that it will move from 0 position to the home position. And then when I press execute, it will actually do that motion. So I combine this with simulation with the 0 simulation, and I can actually move the arms in the gazebo by sending the commands using this move package. So now the arm is at the home position. I can send it from home to left side. So I say plan and execute, and it will compute internally what would be the best possible shortest path for the arm to move from the home position to the left side, and it will perform that action. So basically it is sending all these commands on the topics to the controllers. So for the arm,
Yeah, Ravi, you're cutting out right now. We can't hear you.
I'm sorry for that. I was talking about how the commands are sent to the arm joints. So these are the topics. So basically it takes follow joint trajectory as a topic, and all the commands are sent on this topic. From the movie to the, so the individual joints get the command. Each of the joints, the movie calculates, it does the inverse kinematics, and it knows what should be the joint position. So I have like 5 joints in this arm, and each of the joint according to what should be the position of each of the joint, because it let's say if I want to send it to from home to the left side of the rover, so in the space each joint has some position for this left side position. So what movie is doing, it's sending these commands to each of the joint by doing the inverse kinematics inside itself. So I just have to define some position in the space, and then I can simply say, oh, hey, move it from this, now go from this position to that position, and that's all it does for us. Move it is basically used for simulation purposes, so that you know that your model is working as you want, the kinematics are working fine on them.
Yeah, so that's really good, Ravi. I think let's stop there for now. I don't want to take up the whole time, but that's really good. Any questions or any last things, Ravi, you want to talk about?
So I believe the next step would be to start working on the hardware front. We would like to develop the code further and to be able to control the motors, the physical motors of the rovers and the arm. So we will see how it goes in the coming days.
Yeah, our next step is to so I've got the rover arm. Well, both the rover and the arm are built, and I'm currently using Java to control the arm and the rover. And so our next step in ROS is to get the Dynamixel motors to run for the arm using Move It and ROS, and then same way with the motors on the wheels. We want to get those set up so that we can use ROS, so we can drive in the physical world or move the arm in the physical world. That's kind of the next step.
Yes, this would be the next step to go for.
Great work, Ravi. Allan, that looks really cool.
Now, I think Allan has made the repository public. Anybody can go and visit the code and point out improvements, suggestions, and we will be very happy to have people involved in that also.
Yeah. All right. Well, good. Thanks, Ravi. Yeah. So while I put in the chat, I went ahead and made that GitHub repository public so that you can see the code. And then in the GitHub, there's also links to videos. So at different points in the code, we have different versions. And there's a YouTube video at different points in the process. And then there's also the commands you would use to run the code at the different points along the way. So it starts out pretty basic, but then we get more and more involved as you go along. So if you wanted to go from more basic to more advanced, you could follow the README in GitHub and do that. So that's all I had for tonight for an update.
That looks really good, Allan. Inspirational.
It's a little scary at times.
Allan, excuse me, what are you trying to achieve with the arm? Maybe I didn't understand with the audio.
Yeah, so this would be for driving in vegetable crops, and I'm not sure which is the highest priority use case, but there's several different use cases. One would be visual inspection of the crops and to look for insect damage or weeds. And so we can, with the vision, we'll be able to better identify insect pressures, possibly even seeing some of the insects. You can tell whether there's eggs present or worms present before the, very small, when the worms are very, very small before they get to be at a point where they cause damage. So first would be just the identification of problems. And then the second would be figuring out, how do we treat the problem? So if it's insects, there's certain organic sprays that we could spray, and we could be very specific about where we spray rather than blanketing everything. We could spray very specifically. And then same with weeds. And there's possibly the option of doing something with like flame weeding with propane fire to burn the weeds. We could do something like that. And I think, just generally speaking, though, the rover itself being able to visually observe the crop and record images of how the crop looks on a day-by-day or week-by-week basis, I think that'll help a lot as well. So just driving the rover through by itself would add a lot.
Is the arm manipulation to manipulate a camera, like at the end of the arm, or a sprayer?
Right. Right now, I don't have a camera on the end of the arm, but we could do that.
When you said flame weeding, that sounds scary. An army of fire-breathing rovers.
What was even scarier? I went to an organic conference earlier this spring, and I saw this technology, and this has been around, I guess, since the 70s or maybe even before that, but they were using electricity. They had this huge generator that was, and then these metal bars that were going out just above the ground level. And when it hit a weed, when that bar hit a weed, it would electrify the weed and kill the weed with electricity. I thought that was just about as scary.
So the bar was kind of stable,
Sure.
like it was an electric bar, it was stable, and I guess if the weed grows tall enough,
Right.
it'll zap it.
Yeah, it would short out. It would create a short between the ground and the weed. So
I think that's more dangerous than the chemicals.
Burn your field down.
No, you can electric shock,
Oh, electric
Right.
shock.
a flame. The two things are in last year when we went to the ACBOT, they were working with something that in Argentina they are looking at very steady, is using microwaves.
Sure.
And I think that maybe that's a better way to go. Not sure with the I don't know the bacteria. What you are doing with that with the heat. I'm not sure if it's healthy for the soil, but maybe it's something interesting to work with. And I'm continually thinking on that because I saw some videos about microwave guns that maybe you see it in YouTube.
Technically organic.
Yes.
I've just posted a video, yeah. Why do people not like physical weeders? Because I was thinking like that's, you don't have to replenish any fuel, any electricity or flamethrowers or anything. But I guess maybe energy consumption is a problem. Physically weeding out the weeds is not so efficient.
Yeah, and I think I think this is just an entry point too. The harvesting is a big thing. So harvesting a lot of vegetable crops is pretty manual. Transplanting is pretty manual. So both of those operations, once you figure out how to drive autonomously, and then maybe your attachment, maybe an arm isn't even the best attachment. I'm sometimes wondering if an arm is the best attachment or not. But anyway, I think an arm would be really useful for harvesting in a lot of cases, especially like today. A lot of the times when harvesting is done, it's take the whole crop out at once. So if it's peas or green beans or something like that that can be picked, today it's come in and take out the whole field at once. But you could probably you could probably spread the harvest out over 3 or 4 weeks and pick each individual pea or each green bean at its optimal point rather than all at once.
Yeah, I remember when we were doing spinach, like at a smaller scale, you make more money if you can harvest it like 3 times, rather than just like uproot the whole thing. Like especially
Right.
big spinach leaves, not the baby spinach, but the big leaves.
Exactly. Yep. Exactly.
So I was actually thinking a spinach harvest, then something I could lease out to farmers, because I'm always thinking about the commercial side when it comes to this, like, because if it can't fund itself, it's just going to be so difficult to keep doing.
Right. Exactly.
Really cool, Alan. Thanks for showing that. Any other updates? John Lee, do you have local or indoor localization done?
Oh, hey, Matt, not yet. So looking into the localization, so I assume the visual base is one of the approach, right?
What was that? I
The
broke up.
camera-based localization is one of them.
Yes, camera is one of them. You can use laser or different technologies.
You still need to have the GPS,
No,
MU included.
no, none of that. Just use that. That's your IMU, your GPS, everything. And it's good to learn how to use these fiducials for even outside for other things. But if you
Right,
just use that, it tells you everything. If you want to get, your robot came with one of these little gears.
Yeah, that's a speed encoder.
Yeah, well, there's a sensor that wraps around this, and it counts those pulses. And if you want to get fancy, you can add wheel encoders to your little robot, and that will be similar to your bigger robot that has wheel encoders. But the fiducials tell you everything. It's like a dual GPS.
Oh, that's a need. I see. But mainly for the indoor, right? For outdoor,
Totally.
you still need a GPS.
Yeah, but you're going to move your tractor into your barn. You're going to move in and out of stuff under trees.
Yeah. For that, actually, I want to ask. So I probably need the extra sensor for that speed feedback control, right? You are talking about. I need to buy a new sensor for that.
Yes, they make a sensor that wraps around that counts those pulses. And
right.
Yep.
I see.
I would like to add what Matt showed. The paper which Matt showed, it's called Akuro markers. You use those Akuro markers to calibrate your cameras or do simple things, mostly used for computer vision. If you want to develop an application, you want your rover or robot to follow you or to identify some objects using the camera, you can use those markers. There are various patterns available online. You can see them, you can download, you can print them, you can train your model on top of that. I also work as a full-time engineer in one of the companies in Bangalore, India, and we are developing a robot which is going to be used in hospitals, COVID hospitals. So these are the hospitals where all these COVID patients will be quarantined, and at that time you are not allowed to go into that ward. So all the medicines and food will be sent using this robot. So we have been doing these tests lately using those markers in order to train the model so that we can deploy it and it can tune itself. It knows what environment it is in, what kind of objects it has to see, and whether it's an obstacle, whether it can pass through it. It can help the system to identify the humans, the objects, non-movable objects, movable objects, and all this.
Yeah, it's a good computer vision problem.
Yes.
And it gives you localization. So though all of the things that you learn in setting that up are useful later on or in other ways. So it's not throwaway.
Yes.
Mm-hmm. Yeah, so that's this week's plan then. task for this week. So I wonder, actually, one question is about the overall kind of, you know, a plan, like after this localization, right? And then probably obstacle avoidance. So what's the overall like node map? You have a node
Yes.
map development somewhere, I believe, Matt.
Not totally, but the complexity is going to increase, and that's kind of the game where you're going to get you're going to get this robot driving around. You're going to understand how fiducials work and localization, maybe wheel encoders, and then you'll move on to navigation. So navigation stack is what Allan was talking about, the move base flex, where you can or do dynamic planning in RViz. You send it on a 2D nav goal, it drives there, and then you can send in a planned path. You can do all of that with a little robot, but so we're going to just keep adding layers of complexity. Localization is a complex problem in robotics. So just start out learning one way that you can localize a robot, and then you'll start to learn other ways, GPS and other ways. But to add complexity to your robot, you can, for the navigation stack, once you learn how to use fiducials for localization, you can follow the tutorials on how they set up the liner robot. And that will tell you how to use the navigation stack. And it also adds in outdoor localization. So outdoor localization is a little bit different animal, but you just learn one and keep adding to it. But this one will teach you how to set up control loops around your speed, because right now you're basically just driving your robot open control. So you move the joystick, you see how fast it's going, and then if you want it to slow down, you slow it down. But we need some way to start to control speed and other things. And so that's where the next level of robot is this liner robot. If you look through those tutorials and see, you'll start to see, okay, now we're adding more functionality,
Matt, where are these tutorials located?
So I posted in the chat of the liner robot. Juan does a phenomenal job there. It's a really good robot, even just to understand the different components and how the software stack goes together. And then he'll teach you how to do the PID control loops around your speeds, and then moves on and teaches you how to do navigation stack. That's all in that one link there. And the software is out on GitHub. But if you want the one, so his robot's a little bit more complex. But if you want, like, we're trying to figure out what the right pathway is, but you can use the simulator. The simulator that Vinny has, all of that. You can do all of this stuff in simulation. Even the fiducial tracking, fiducial following, all of that can be done in simulation with no hardware. But if you want the first hardware project, this one is great. I have two of them. They're really fun, and you can think around and learn a lot. And then this one, we just use real simple tutorials on how to get this to drive, how to load the software on the Raspberry Pi and things like that. Worth doing. And then next step, add more sensors, add localization, and then we'll keep adding to it.
Thanks for that.
Have a lot of fun.
Real
Instruction.
real fast, to test, assuming I get polygon area coverage working, you mentioned you had two of those little robots. We might be able to test on using that if we all want to do a hardware test.
Let's do a hardware test.
You can remote log in, right? I guess, if you want.
Yep. John Lee, we're going to put 0 tier on your Raspberry Pi. That'll give us VPN access, and Vinny's going to be driving your robot around.
That's a good idea.
So actually, my alma mater, Georgia Tech, they have a robotarium, and it's
Whoa.
this huge room, and it's an area, and they have drones in there. They have little robots in there, and you can request time slots. I mean, I guess universities can request time slots. I don't know if they've opened it up to everyone. Yeah, and to test your swarm algorithms. Ducky Town has similar, arenas set up to where you can request remote access, and you can actually drive in these arenas autonomously. Quick sidebar.
Auto rally.
No,
Oh,
what
sorry.
you'd want to search for is Georgia Tech Robotarium.
How about, so Vinny, is this, is this part of Georgia Tech right here? Is that,
It looks like it. It looks like it. I was not involved in that project.
okay, this was a very cool project that I watched, looked at quite a bit. So, and that, I think this is Georgia Tech.
Yeah, it definitely says that in the description, but I've never heard of that project before.
Okay. It's, anyway, it uses reinforcement learning. So they drive it around the track I don't know how many times, a dozen times or whatever. And it learns as they're manually driving it. And then they switch it over to self-driving. And it starts out driving fairly slow, but then they've optimized it to gradually increase its speed up to the right speed. So it goes faster at certain points on the track and it slows back down again. So I don't remember exactly what they were trying to maximize the time around the track without running off the edge or something like that. So, but it was a great reinforcement learning approach that they used. So anyway, I thought maybe
pretty cool. Do you mind?
Oh, so go ahead.
No, I wasn't. Do you mind dropping that into the chat?
Yeah. I did a Google search, but it's this one that comes up here. So.
Okay.
Sorry to jump in. I would like to show you guys a small video about the obstacle avoidance testing, what we are doing nowadays. Alan, it's okay if I share my screen?
Yeah, go ahead and share. We're having a hard time hearing you, so
So
let's see how it goes.
I'm saying that I want to show you a video where we are testing obstacle avoidance in the room we are developing. Are you guys able to see?
Yeah, we can see.
Cool.
Is that something, Ravi, is that something you helped with?
Yes. We are working, the company in which I work, we are developing this small form factor robot for the hospitals. We are going to deliver the meds and food to the patient, the COVID patient. So in these wards, you are not allowed to go inside. They are COVID wards, they are quarantined. So you send all the necessary items in the ward using this robot.
So it's a hospital application.
It's a hospital application, yes. With the recent pandemic situation, the company started to think, and we got the opportunity, we got the order, and we developed this robot in a very less amount of time. And right now we are testing this robot, and next week we are going to deliver it.
So because of coronavirus, they're working on a solution, and he says it's going to be delivered to the hospital next week.
Yes.
All right. Well, thanks, Robbie. That's really good. I don't know if you can find the chat window for Zoom, if you have a link you can share, or maybe you can't share it yet either. But anyway, we're at the top of the hour, so we're actually past the top of the hour already too. So unless
Try to upload this video in the chat, but I don't think I can upload it. Sorry. It
yeah,
doesn't allow me to upload.
okay. So I don't know, Matt, if anybody, it's time to wrap up, or if anybody has any last minute things they want to ask, or otherwise it's always good discussion. I appreciate the input.
Yeah, it's great seeing everyone tonight. Thanks, Allan.
Yeah, thanks everybody.
Nice work.
Bye.
Bye-bye.
Bye. Talk to you soon.
Bye.
Bye-bye.
Bye.
Bye-bye.